Welcome to Legrand's Data Infrastructure Instructional Series. In this module, we'll be discussing the setup process to use for the inspection, cleaning, and testing of the very small form factor connectors that have recently been developed. While the process shown in this video will apply to all VSFF connectors, it will be specifically addressing the MDC connector. It's important to note that this is a generic method as it pertains to tester brands. As long as the user understands how to set the reference on the unit they are using, it can be applied to any brand of certification tester. These VSFF connectors are so new to the market that tester manufacturers have not yet developed the adapters and software to guide installers through the one-jumper method defined in the TIA standards. For that reason, a slightly modified version of the three-jumper reference must be used. While it's understood that most viewing this video are doing so simply to understand the three-jumper reference process, it's also important to mention that each of the end faces on our test reference cords have been cleaned and inspected. For detailed information on cleaning and inspection, as well as some other testing considerations, skip ahead to the timestamp shown on this slide. The product that you'll need to perform this referencing and the following testing includes your tester and the test reference cords that you would normally use to perform a single jumper reference, such as a pair of SC to LC cords and a pair of LC to LC cords. In addition, you'll also need an LC to LC substitution cord, a pair of LC to MDC breakout cords, 2 LC duplex couplers, and an MDC coupler. All cords should be reference grade per the TIA recommendations. The substitution cord, breakout cords, and adapters are available as a kit from Legrand. A few quick notes on setup. Please ensure you include the test parameters for reference grade cords so that the tester only allows 0.5 dB for the first and last mated pairs. If you use the setup for standard grade cords, the tester will allow 0.75 dB for all mated pairs. As you go through the referencing process, ensure your cords are as straight as possible. Any sharp bends or coils introduce small amounts of artificial loss into the reference. When those bends are removed, the cords will perform slightly better and reduce the accuracy of the results. Finally, as you go through the process, and then as you test, clean your test reference cords every single time you mate them. Contamination is the leading cause of issues with fiber and can damage expensive reference grade cords. To properly implement the three-jumper reference and ensure your cords are performing properly, it should be a building process starting with connecting the testers directly, referencing, and performing a series of test reference verifications along the way. Begin by directly connecting the units as shown here. As mentioned, this is a tester agnostic process, so proceed to the Set Reference screen on your device. Set the reference. After the reference is set, view the reference values and ensure they are within the normal values for your device. Values outside the norm could indicate an issue with either the tester or the test reference cords. Now, disconnect the receive connector from each side as shown. Please note that at no point moving forward should the connector be removed from the transmit side of the tester. Couple the testers back together as shown. Perform a test reference cord verification by pressing the test button on your unit. At this point, it will be the responsibility of the technician using the tester to verify the condition of these test reference cords by ensuring a result of 0.25 dB or less for single mode, or a value of 0.15 dB or less for multimode. Anything less than around 1 dB is going to show a pass on the tester. Again, these values require a pass-fail by the tech based on these numbers shown. Save the result to include with the test results to show the process was followed. We recommend using the nomenclature TRC1 with the date and time to follow. Without changing the cord configuration, again, set the reference on the tester. Disconnect the LC connectors from one side of the coupler as shown. Insert the LC to LC substitution cord. Again, perform a test reference cord verification by pressing the test button. It will again be the responsibility of the technician to manually pass-fail based on 0.25 dB for single mode or 0.15 dB for multi-mode. It's critically important that the value of this test is as low as possible. It's strongly recommended that even values in excess of 0.10 dB have care taken to reduce that loss. Clean the connectors again and ensure any bends in the test leads are removed. There is potential for losses in this step to be included in the final reference and then contribute toward optimistic test results in the cable plant. The recommended nomenclature for this save is TRC2 using the same date and time as before. Without changing the cord configuration, set the reference on the tester for the final time. Now, remove the substitution cord, but leave the couplers in place on the LC connectors. Connect the LC to MDC breakout cords as shown. Note that for this step, you'll need to flip the polarity on one of the MDC connectors. To flip the polarity, simply grab the boot in the connector, slide the boot back, rotate the body of the MDC connector so that the writing is now upside down and the triangle is on the bottom, and then slide the boot back. Perform the final test reference cord verification by pressing the test button on your unit. Again, the technician will have to manually pass-fail based on 0.25 dB for single mode or 0.15 dB for multi-mode. Save this TRC check with the recommended nomenclature of TRC3 using the same date and time as before. You can now test your very small form factor connections. Depending on the polarity of your VSFF connectors, you may need to remove the polarity reversal we inserted for the test reference cord verification. If you're testing the MDC side of Legrand's acclAIM solution, keep in mind that it's a method C polarity and the reversal we added will have to be removed. As a note, you can now go back to the pass-fail criteria set up in your tester. Keep in mind that this process has shown the use of reference grade cords. If you're using the TIA 568.3 test limits, ensure you've included reference grade cords in your setup. As has been mentioned, cleaning is the single most important consideration when working with fiber. When we consider the core sizes of both multi-mode and single mode are smaller than a coarse human hair, it's easy to imagine losses can be extreme if dust prevents the light from moving through the core. Always use approved cleaning products and follow the recommended manufacturer process for each device. Lint-free wipes and other dry devices such as OptiPop or the clickable cleaners should be used. Only use liquid cleaners when necessary, and only use cleaners meant for use in fiber optics. As you saw from this video, properly referencing the units is an investment in time. We strongly recommend that you use a fiber optic scope to visually inspect the end faces on all of your connections for the test reference cords. Ensure that they are unmarred and free of contamination. Taking this small preventative measure can ensure a smoother process. It's important to keep in mind that this 3-jumper reference introduces additional variables that are not seen when using the 1-jumper method. We have 2 mated pairs that are built into our reference, and then 3 mated pairs for the test reference cord verification step. With all of these variables, coupled with the high performance of the VSFF connectors, it's possible to see apparent gains in light in the form of negative loss values. This becomes even more likely when testing short lengths of fiber. Here's some science to explain this possibility. Our fiber losses are expressed in decibels, which is really a logarithmic format for a percentage of light. 0.05 dB is a loss of about 1% of the light. Go back to our last reference configuration. We have 2 mated pairs. If there is a variation of only 1% in each mated pair, we can better our values in the test by 1/10 of 1 dB. In our testing setup, we have at least 4 mated pairs between each tester. Here we can see 0.2 of a dB of variation. If this high-performance cable link is performing at 1/10 of 1 dB, we could potentially see a negative loss. Different tester manufacturers handle these losses differently. Some have a failure at different values, others have a warning. It's up to the technician to understand what those are. If you're seeing consistent negative losses in your tests, it's best to go back through the referencing process, ensuring all cords are straightened. It's likely that some accidental loss was built into the final reference. As an example, consider the small surfaces most commonly used to perform the reference. Test reference cords are coiled, sometimes kinked, and the reference is set. When the coil or kink is removed, the loss that was created is removed but still exists in the reference value. It's very easy to have a 2% loss of light in the coil, introducing a full 1/10 of 1 dB in the reference that will be removed when we straighten the cords and start testing. It will be even more likely in multi-mode fiber that doesn't have the bend-in sensitivity that single mode does. This will result in optimistic test results, and in high-performance systems could appear as a gain in light in the form of a negative loss. Again, referencing is a critical step to ensure accurate results for the system that will be in place for years to come. Thank you very much for watching the video on testing very small form factor connectors. If you have any questions on the subject, please feel free to reach out to us here at Legrand on the information shown on the screen.